Good morning. Good morning to everyone. Okay. Fine. So, before going to today's concept, we'll have a discussion about yesterday's one, right? Now, what we have discussed in the yesterday's class, we have discussed about electrophilic substitution reaction, right? That is related to aniline. Electrophilic substitution reaction related to aniline. Now, when I am talking about aniline, there will be presence of positive resonance. It will show the positive resonance, right? Right? So that's where we have the positive resonance. So Dhanalakshmi, yes, you are right. Electrophilic substitution reaction with respect to, I was talking about aniline. So where we will be having positive resonance. Due to the presence of positive resonance, what will happen? There will be more electron density at ortho and para position. So there will be presence of electron density at ortho and para position. So they are ortho and para directing. Which one? Aniline. Aniline is ortho and para directing when it comes to electrophilic substitution reaction. Now, we have another condition where we have anilinium ion. We have the anilinium ion where there will be an intermediate where amino group will be having positive charge. Where amino group will be having positive charge, right? So during that time there will be formation of positiveness because there will be shifting of the electron. There will be shifting of the electron. So what I mean to tell you is due to the presence of anilinium, ion, that can also have impact on the electrophilic substitution reaction. Where due to the presence of, okay, so due to the presence of positive charge, now what will happen? Some of the electrophiles can attack the meta position. Some of the strong electrophiles can attack the meta position where electron density is considerably fine when it comes to ortho and para compared to ortho and para. That's what we have observed, right? So now, among the electrophilic substitution reaction, we have discussed about halogenation, then we have discussed about nitration, then we have discussed about anything else? Halogenation, nitration, sulfonation, right? So we have discussed about the sulfonation. Now when it comes to halogenation or nitration,
So in the diagram which you drew,
huh?
N had positive and all the sides also had positive.
Where?
In the previous.
That is anilinium. Anilinium, since it is having positive, so therefore I was telling that even it will pull the electron away from the ring structure. Now, when I am talking about halogenation, okay, Mayank was having a doubt that I had written this particular structure, right? NH2 positive, and I had shown positive here. So that is just to indicate that since there is an anilinium positive charge, it will pull the electron, it will show the negative resonance, due to which there will be electron density which will be less at ortho and para. Just to represent that one, I had written like this, fine. So that's what? That's where we have the anilinium ion condition, which will show the negative. Otherwise, amino group will show the positive resonance. Fine. Now, when it comes to halogenation and nitration, for both the things, one thing is that we have to go for pre-treatment. So, what is that pre-treatment? Pre-treatment is where aniline, it will be undergoing for acylation reaction by using acetyl chloride or acetic anhydride, anything, acetic anhydride. Any of these two reagents will be utilized where it's going to modify the amino group NHCOCH3, right? Acetanilide, there will be formation of acetanilamide. Now this is amine, this is aniline, acetanilamide. So that's where we have the conversion. Then it will go for halogenation or nitration. If I want to go for bromination, then bromine water I will use. And if I want to go for nitration, I will use HNO3 and sulfuric acid combination. HNO3 and sulfuric acid combination. So that's where I have the nitration and that's where I have the halogenation. In both the cases, para-substituted product will be a major product. So that's where we are going to get the mono-substituted product. So if you are not going with this treatment, what will happen? So when it comes to the nitration, there will be formation of ortho, meta and para-substituted molecules. Contamination, right? Same way, when it comes to here, polysubstituted or multi-substituted products will be there. Multi-substituted products will be there when it comes to halogenation. So to avoid that, we are going for this particular conversion. All of you have understood? So that is for halogenation and that is for nitration. Now when it comes to sulfonation, whether we require this pre-treatment? No. When it comes to sulfonation, there is no requirement of this particular treatment. So what they will do? They will treat with the concentrated sulfuric acid directly. Aniline will be treated with concentrated sulfuric acid and that's where there will be NH3 plus. So from where this NH3 plus came, that is from the H plus released by the sulfuric acid. It will take that particular H plus because it's a Lewis base, right? And there will be for presence of hydrogen sulfate, bisulfate ion. There will be presence of bisulfate ion. That's where we have the conversion. There is no requirement of acetylation or acylation. Fine. Now, further, once again it will be treated with sulfuric acid. That's where we will be having, what is this molecule? I told you should remember this molecule. Only major product I have written. What is this molecule? It is sulfonilic acid. It is nothing but sulfonilic acid. Now, what is the IUPAC name of sulfonilic acid? Sulfonilic acid IUPAC name is 4-aminobenzene sulfonic acid. So 4-aminobenzene sulfonic acid, right? So that is the IUPAC name, 4-aminobenzene sulfonic acid, right? Which can also be called as para-aminobenzene sulfonic acid. Yes, Bharat, very good. So the last very important point, try to discriminate between halogenation, nitration and sulfonation. Fine? So that try to discriminate between these reactions. And another important point, as Bharat has told, yes, when it comes to aniline, it will not show the Friedel-Crafts reaction, right? It will not show the Friedel-Crafts reaction. Why? Because aniline will make a complex with, or amino group of aniline is going to react with the Friedel-Crafts catalyst. That is aluminium trichloride or FeCl3. So because Lewis base, Lewis acid. So they are going to make a reaction with each other. So due to that, aniline will not show the Friedel-Crafts reaction. Then someone had asked, I think Dhanalakshmi or someone, they had asked, I have forgotten, or Purnima, I don't know. So they had asked that, in that case, how to go for acylated product for aniline. And as I told, aniline directly cannot go for acylation. We have to make nitro derivative, then go for acylation, and once again convert that one into aniline. Got my point? Or from nitrobenzene we can convert them into aniline. Fine? So that's where we have the acylation reaction with respect to aniline. As it is aniline, it's difficult to have the acylation. Fine? All of you have understood? Now we will move to the next one. 1 mark question or 2 mark question you can expect from this particular concept. Fine? So that is diazonium. Already we have discussed diazonium salt. Okay? Now whenever I am telling diazonium, we can represent that one as N2 plus. Please remember, I have not written simply as N2, which is nitrogen, elemental form of the nitrogen. I am not talking about N2. I am talking about N2 plus, where one of the nitrogen is carrying positive charge. Right? So naturally it should be a good electrophile. So that's where we have the diazonium. Right? So if I want to go for general equation, for diazonium compound, then I can write it as R N2 plus X minus. Just like Grignard reagent, where Mg, nitrogen, this one will be replaced by the Mg, right? Grignard reagent. So that's where we have the diazonium compound, general equation, R N2 plus X minus. So there will be presence of covalent bond and there will be electrostatic interaction, just like Grignard reagent. That's what I was telling. Fine? So if I want to have the diazonium, then N2 plus. If I want to go for general equation for diazonium compound, then this will be the general equation. Okay? Where R can be either alkyl group or aryl group. Where R can be either alkyl group or aryl group. And anyway, N2 plus is diazonium ion and X minus is respective halide. So that's where we have the general formula for diazonium compound, where R can be alkyl or aryl group, N2 plus as we have discussed, that is diazonium, then X minus can be halides, respective halides. Say for example, if I have CH3 N2 plus Cl minus, then I can straight away from left to right I can read it. CH3 means methyl, N2 plus means diazonium, then Cl minus means chloride, methyl diazonium chloride. Now instead of alkyl group, if it is benzene ring which is attached, then I can call it as benzene diazonium chloride. Benzene diazonium chloride. That's how we can write the name of the molecules. So depending on the R, name will be vary. Depending on the X, name will be varied. N2 plus will be constant, which is diazonium. Okay? So any doubts? So that's where we have the compounds. That's where we have the diazonium compounds. Any doubt in this? Any doubts? Correct. When I am talking about benzene diazonium chloride, benzene diazonium chloride or halide, any of the halide, either chloride or bromide. Now they are the one which are stable among all the diazonium compounds. They are the one which are stable. But please remember, they are stable at low temperature. They are stable at low temperature. Please remember, even other diazonium compound, they were not even stable even at low temperature. But at least these are the compounds which are stable at low temperature. Right? So therefore, we can make a statement. Alkyl diazonium halides are unstable even at low temperature. Even at low temperature. But benzene diazonium chloride, they are at least stable at low temperature. Chloride or bromide, they are stable at low temperature. Because stability is not decided by the halides. Stability will be decided by the ring and the diazonium. All of you have understood? So that's where the stability. Now the question here is, why benzene diazonium halides, they are stable compared to other diazonium compound? That is the question, right? So that is due to the resonance effect. That is due to the resonance effect. Fine. Now where nitrogen will be having positive charge. So nitrogen will have the positive charge. And this is the benzene diazonium ion. Okay. There is no halide. I have not represented the halides. Benzene diazonium ion. Okay. Now, due to the presence of positive charge, it will try to pull the electron from the neighboring carbon. Because this nitrogen, they are equally potent or equally equipotent. They are equipotent. So therefore it has to torture the carbon. It cannot torture the nitrogen. But this nitrogen will help in taking the electron, because then only it can make the double bond here. Nitrogen cannot make 5 bonds. So this one single double bond will be shifted to this nitrogen. So that's where there will be formation of a double bond. That's where there will be formation of a double bond. Negative, positive. So there will be positive density, because electron has been shifted there. Right? So now, due to the presence of positive charge, now it will be pulling the electron from the neighboring carbon. So that's where we will be having nitrogen, negative, positive, and double bond is formed here. Right? Since electron has been shifted to here, now this carbon will attain the positive charge. Now, even this will be shifted. Even electron from next pi electron will be pulled towards the positive charge. Now, due to that, now there will be formation of positive charge over the ortho position. Right? So that's where we have the condition. Now there will be reformation. There will be reformation. Right? So that's where original structure will be formed. That's where original structure will be formed. So that's what it will be there. If you observe, double bond position has been altered. Right? So in that case, diazonium, which is attached to the benzene ring, whether it will show the negative resonance or positive resonance, because there is a formation of positive electron or electron deficiency on the ring structure. So whether it will show the positive or negative resonance, naturally it should show the negative resonance, and due to the negative resonance there will be formation of electron deficiency in the ring structure. Yes, Kritik, very good. It will show the negative resonance. All of you have understood? So diazonium attached to the benzene ring, and due to the resonance feature, diazonium salt related to benzene ring, it will be stable compared to all the other azonium compound, diazonium compound. All of you have understood? This is the reason why benzene diazonium compounds, they are stable. Fine. Now when it comes to preparation, already we have discussed many times, we have discussed preparation. That will be the first step in Sandmeyer's reaction, if you recollect. That will be the first step with respect to the Sandmeyer's reaction. So what they will do? They will take up the aniline, right? This is nothing but aniline. Now this aniline will be treated with NaNO2 plus HCl. NaNO2 plus HCl. What will be the temperature? Temperature will be somewhere around 0 degree Celsius, 0 to 5 degree maximum, right? Or you can mention it as 280 or 270, better is 270 Kelvin. So that's why low temperature will be maintained. There will be formation of benzene diazonium chloride. Benzene diazonium chloride. So what is the use of NaNO2 and HCl? NaNO2 HCl, they are going to help in the formation of nitrous acid, that is HNO2. They help in the formation of HNO2, right? So that's where we have the reaction. Naturally, another product can be NaCl, which is a salt. Anyway, we are not interested in NaCl, which is a salt. We want benzene diazonium chloride. We are interested in this particular compound. Now, only thing here is whether I am talking about benzene diazonium chloride or any of the benzene diazonium halides, they are not stable. They are stable at cold condition, but bit increase in the temperature, they will get hydrolyzed. So therefore, major application of this compound here is they are used in the preparation of many of the organic compound. That's where they have the huge application in organic chemistry. Preparation of organic compounds. Got my point? Therefore, whenever they are synthesized, immediately they will be utilized. They will not be stored. See, just like ammonia or benzene, hexane, solution will be having, right? Solvents. We will keeping that one into the brown bottle. But that way we cannot keep this chemical, benzene diazonium chloride, we cannot store it for a long time. So therefore it will be prepared and immediately it will be utilized for the synthesis of required compounds. That is the application of this benzene diazonium chloride. It is having huge application in the preparation of many of the organic compounds, even organic dyes, not DIES, DYES, dyes. Anyway, we are going to discuss that one. That is coloring compounds. So benzene diazonium halides chloride is prepared and it will be utilized for the preparation of many of the organic compound and even preparation of organic dyes. All of you have understood? Fine. So that's where we have the benzene diazonium chloride preparation. and it cannot be stored. Right? All of you have understood? Now, first reaction, even this one, as I told, first one will be Sandmeyer's reaction. Naturally, since it is repeated many times, so we can mention it as very, very important. This reaction we have discussed many times, right? Now, this particular reaction where we have the benzene diazonium chloride, we have the benzene diazonium chloride. From where this benzene diazonium chloride came? It came from the aniline. Okay? So that's what we have discussed in the previous reaction. So this benzene diazonium chloride, whenever it is treated with cuprous chloride, Cu2Cl2, not CuCl2. CuCl2, if you write, it will become cupric chloride, right? So don't write CuCl2. That will become cupric chloride because copper is +2. So I am talking about Cu2Cl2, that is cuprous chloride. Since they will be in dimeric form, therefore we will write it as Cu2Cl, cuprous chloride. Fine. In the presence of HCl, same way, if I take Cu2Br2 in the presence of HBr, respective hydrogen halides, to avoid the contamination, respective hydrogen halides will be utilized. Fine. Now, what will be the products, or what are the products? So here it will be chlorobenzene. That's where we have discussed in the preparation of haloarenes, right? So chlorobenzene and nitrogen gas. So here it will be bromobenzene plus nitrogen gas, right? So that's where we have the preparation of chlorobenzene and bromobenzene from aniline. That aniline I have not written here. If you want to write, so that's where we have the aniline. NH2, when you treat with the NaNO2, sodium nitrite and HCl, somewhere around 275 Kelvin. So we are going to have the intermediate, which will get converted into respective haloarenes or aryl halides. So chlorobenzene and bromobenzene. That's where we have the Sandmeyer's reaction. So same way, Sandmeyer's reaction is also applicable for conversion of benzene diazonium chloride to respective nitrites, CuCN, cuprous cyanide, okay, in the presence of hydrogen cyanide. Now there will be formation of what is this molecule? It's a benzonitrile compound, right? So that's where we have molecule, or phenyl nitrile, anything is fine. So phenyl nitrile, that's where we have the reaction. All comes under Sandmeyer's reaction. Now, if you observe it carefully, they have used respective copper with respective halides and cyanides in the presence of respective hydrogen halides and hydrogen cyanide. That is the combination when it comes to Sandmeyer's reaction. Don't forget, because we are going to discuss about similar another reaction, right? One of the product will be nitrogen gas and respective organic compound will be synthesized. This is the easiest method for the preparation of chlorobenzene, bromobenzene or phenylnitrile compounds. This is the easiest method. All of you have understood? So, ಹಾಗಾದರೆ if in the examination for 2 marks, if they ask, write the reaction involved in the conversion of aniline to chlorobenzene, which it was there in your haloalkanes and haloarenes topic also, here also, right? So this is the reaction we should write. So 1 mark for this reaction, 1 mark for this reaction. If you have not written the condition or catalyst or reagents, then you are going to lose the marks. Definitely you are not going to get the complete marks. All of you have understood? So this is Sandmeyer's reaction. This is nothing but Sandmeyer's reaction. Fine? So that's where one of the application of benzene diazonium halides. That's where we have the benzene diazonium halides. Now if you observe it carefully, I have not written or I have not removed very important. That is because we are going to discuss about another important reaction, that is Gattermann reaction. Not Gattermann-Koch reaction, it is a Gattermann reaction. Okay na? So that's where we have the reaction, Gattermann reaction. Now when it comes to this particular reaction, once again, it is for the conversion of aniline to chlorobenzene, another method. Aniline to bromobenzene, another method, along with the Sandmeyer's method. So N2 plus Cl minus NaNO2 plus Cl. So now next step is they are not using copper halide, they are using copper powder. They are using copper powder in the presence of HCl. In the presence of HCl. Now they are going to get chlorobenzene. They are going to get the chlorobenzene. Okay? And instead of nitrogen gas, it will be respective copper halide. Since we have taken benzene diazonium chloride, we are going to get the copper chloride. We are going to get the copper chloride. Now same way, if I take copper and HBr, copper powder and HBr, now I am going to get formation of bromobenzene plus cuprous chloride. We are going to get the cuprous chloride. So whichever halide is that, respective halide will come with the copper. Okay, cuprous chloride. Cu2Cl2 or CuCl I have written. Fine. So that's where we have the Gattermann reaction. Now what is the difference between Gattermann and Sandmeyer's? That is the only difference here is where we are using copper powder, but then it was copper halides. Right? That is the only difference. Adakoskara heliddu. You should be careful. So that's where we have the Gattermann reaction. But when it comes to yield wise, Sandmeyer's reaction is prominent compared to Gattermann reaction. Sandmeyer's reaction will be giving high yield with respect to respective aryl halides preparation. Got my point? So if I take chlorobenzene, preparation of chlorobenzene, if I have to go for commercial preparation, then I can go with Sandmeyer's reaction because it will have the higher yield compared to this method. All of you have understood. But what is the difference? The difference here is copper halide in Sandmeyer's reaction and copper powder in Gattermann reaction. Fine? All of you have understood? Okay? Both are very important reactions. And I told, when it comes to Sandmeyer's or Gattermann, they are not used for iodination and fluorination. Please remember, when it comes to preparation of aryl halides, they cannot be used for the preparation of iodobenzene. They cannot be used for the preparation of fluorobenzene. That's where we have the iodination, fluorination of the benzene ring. It cannot be done by the Sandmeyer's reaction. Okay, Purnima. Here it looks fine. Buffering. Okay, for others also it is buffering. Students, for others also whether it is buffering. If it is only for Purnima, then network issue is with your this one, Purnima. Even for others, if it is happening, let me know. Okay, no. Purnima, then if it is happening, you have to restart your mobile. Okay, na? Fine. So we will go with the very important point, that is, I was telling very important point, that is, when I am talking about, okay, little, for Amit also a bit it is there. Okay. So when it comes to iodination and fluorination, Sandmeyer's or Guttermann's reactions are not utilized. Remember this. Fine? It will not be utilized. We have the different method. For example, if I want to go for iodobenzene preparation, so what I will do is, I will take benzene diazonium chloride. From where it has been prepared? It's prepared from aniline. From aniline only I am writing because if they ask in your examination conversion of aniline to iodobenzene, then you should write these reactions. So NaNO2 and HCl. So now it's very simple. We have to treat with the potassium iodide. Little video problem. Okay, Amit.